yesterday we talked about, well, not yesterday, but last week, where we had our sum and difference of angles, and we had those three where you had cosine, sine, and tangent when two angles were being added together. And that is going to be in combination with what we're going to be talking about today, where we actually have something called a double angle. Okay, so it's actually two angles that are added together. And what do we, we can do like a little shortcut if we've got a double angle. And given a formula, so if I have sine of 2u, we can use this in order to solve, because what we're going to be doing on this section is we're actually going to be solving again. We have, and I'm going to skip down here to tangent of 2u, and both sine and tangent are pretty straightforward. You just substitute clearly in for the formula that's given. Our problem comes, or our conundrum, we can say, comes when we have cosine, a double angle for cosine. Because with cosine, we have three choices. With sine and tangent, we have only one choice. But with cosine, we have three choices. And as we go through some of our work today, you're going to see where and how we can discern which one of these formulas best fits the equation in which we're trying to solve. So for instance, this first one has both cosine and sine in it. The second one is strictly cosine, and the third one is strictly sine. So on cosine, you have to say, which one am I going to choose? And then we get that emoji of the thinking. Okay, I'm not even going to try. Okay, which one am I going to choose? So what you'll do is you'll look at the equation and get it in terms of sine, cosine, bless you, or both. That's the question we want to ask. Okay, so we want to know, am I going to get it in terms of sine? Am I going to get it in terms of cosine? Or am I going to get it in terms of both? And that will determine which one of these equations we'll use. Okay? And again, just like in 5.3 with the sum or difference of angles, it's very straightforward. You're just plugging in once you can determine, especially with sine and cosine, or sine and tangent. You're just going to be substituting in that equation for the angles that we have. So the first thing we're going to do is we're actually going to prove. We're not solving anything. We're proving. Again, we hear about this fake news thing going on. We want to make sure we don't have fake formulas. So we're going to prove that this double angle of sine really does equal 2 sine x cosine x, which is what we have at the very top. Okay? So when you see this double angle, what you're thinking is this: sine of x plus x. Okay, you're not thinking in terms of 2x, you're thinking in terms of sine of x plus x. Sorry about that. Okay, and where that comes from is that we know that 2 times x is the same thing as x plus x. What's x squared? X times x, absolutely. Okay, so 2x is x plus x squared is x times x. All right, so what I'm going to do is I'm going to substitute in and say that this is sine of x plus x. Does that really equal, inquiring minds want to know, 2 sine x cosine x? Then, and this is where and why I wanted you to have that formula sheet off to the side, because with that, I'm going to use the sum of two angles with sine. This is what we did in 5.3, okay? So by taking that, if it's sine, I take sine of the first angle times cosine of the second angle. They happen to be the same angle, so it makes it kind of nice. And then with sine, the sine, S-I-G-N, actually stays the same, so it stays plus. And then I take sine of the second angle times cosine of the first. But they're both the same. No, don't say what. This is right off this sheet right here. okay? It's right off that sheet. That's exactly what we did in 5.3. Does that equal 2 sine x cosine x, which is the new formula for the double angle? Does it really equal that? So then I ask, looky there, looky, how many sine x's cosine x's do I have? I have 2 sine x cosine x. By gosh, by golly, it really does equal. I wasn't making that up. Okay? So what I'm not doing is I'm not actually using any of the formulas above yet. Okay? We're just proving it. Say that again.
Wasn't like cosine x squared or 2 cosine?
Where are we at?
What you just got.
Because if you're adding, it's 2. It's not squared. It'd be, if this was multiplied, then I would have sine squared, cosine squared. But it's not.
It's all one thing.
It's, yes, correct. Okay, now let's do the exact same thing for tangent. Okay, let's do the same thing for tangent. So I'm thinking, not tangent 2x, but I'm thinking of tangent x plus x. Okay, I'm thinking x plus x. Does that really equal 2 tangent x over 1 minus tangent squared x? We really want to know. So tangent is that long formula. It's adding, so this is being pulled off of this 5.3 formula sheet right here, where I take tangent of the first angle plus tangent of the second angle all over 1 minus tangent of the first angle times tangent of the second angle. Does that really equal that? Well, what is tangent x plus tangent x? 2 tangent x. And here's your question here, Caleb. Tangent times tangent, there's my tangent squared. So it does equal 2 tangent x over 1 minus tangent squared. So there's the proof for sine and tangent. Okay, we could be proving the 3 for cosine, but we'd be here till tomorrow. All right, so, but there's just showing you how a double angle, which we can pull in using a sum, and where these actually came from. Okay, it's not something that was just made up. All right, so now let's go into what we really want to be talking about in 5.4. And this is solving given a double angle. Okay, so we're solving. 90% of the time, when we solve something, what is typically the first step that we want to do if we're solving something? Make sure that it is equal to 0. Okay, so when we solve, we want to set equal to 0. Okay, we want to set equal to 0. Now the second thing I want to do is notice that, and this, except for substituting in for our double angle, the rest of what we're doing today is so yesterday, stuff that we've done before. But what I want to do is I want to change this 0, 2 pi parenthesis. I want it to be brackets on both ends, because I don't want to, if there was a parenthesis there, we could not include 2 pi in our solution, but I just want you to know that whatever we're working, we're not going to be exclusive, we're going to be inclusive. And we're going to keep 2 pi in, so I just changed those to brackets, alrighty? Okay, so the first thing I want to do is, let's set this equal to 0. So I'm going to have sine 2x minus cosine x equals 0. Okay? Now there's my double angle, sine of 2x. I'm going to just do a very quick substitution, and from the formula at the top, I'm going to substitute in 2 sine x cosine x minus cosine x equals 0. Now, if you wanted to say sine of x plus x and go through all the formula from yesterday, go for it. I keep saying yesterday, from 5.3. But you would be doing all of this unnecessarily just to get to this, okay? So we have 2 sine x cosine x minus cosine x. from here on out, this is what we've done before. We're solving in this interval. We're going to need to use our unit circle. I have two terms. So the first thing I want to notice is that what do I have in common in both of those terms?
Cosine.
So let's pull out a cosine x, meaning that is a common factor. So I am pulling out a common factor. So 2 sine x divided by cosine x is 2 sine x. And cosine x divided by cosine x leaves me with 1. And that's a minus right there. That's where that comes from. So once you're in factored form, where we've got one factor being multiplied by the other, then I can set them both equal to 0. So I get cosine x equals 0, and 2 sine x minus 1 is equal to 0. And this should look really familiar. So on the unit circle, you pull out, where is cosine 0? And you will say, at pi over 2 and 3 pi over 2. Pulling out the unit circle. Cosine is my x value. So I look at that x value on pi over 2, and you'll see that it's 0. It's that the coordinate point for that is 0, 1. Sine is 1 at that point. Sine is negative 1 at this point. But both of those are cosine at 0. Now the second one, I've got to do a little bit of maneuvering before I can get just a sine. So I add 1 to both sides, and then I divide by 2. So now I look at the unit circle, and I find out where is sine 1/2. And I see that sine is 1/2 at pi over 6 and 5 pi over 6. And because we're in the full circle, I can use all of these. It's not like where we were looking for the angle measurement and I was in a restricted area. This is the full, I'm given full boundaries for that. So then my solution set, I write as pi over 6, pi over 2, 5 pi over 6, and 3 pi over 2 as my full set. Okay? So the only thing different is just substituting in for my double angle, for my sine 2x. Now, I don't mean to shoot you down by any means on this, and the fact that sine 2x, we only had one choice. It is just 2 sine x cosine x. We didn't have a choice for that, so that was pretty simple. And then moving through that, factoring out and finding that common factor, also pretty simple. So this is probably as easy as you're going to get right here. Okay? We're going to amp it up quite a bit after this. So do I have any questions before we move on to something a little bit trickier? We all good? All right, so the second one. Directions stay the same. Where it says to solve again. So therefore, again, I want to, if it isn't already, I want to set equal to 0, because more than likely, I'm going to be factoring somehow. Just like the one above, I factored finding a greatest common factor. So on this section, you'll be finding common factors again. You will also possibly be doing some trinomial, like the AC method, that kind of stuff, but it'll still be very, very simple, not too horribly difficult as far as the factoring goes. All right, so my first step, I'm going to have cosine of 2x minus sine x equals to 0. Okay, so I want to set that equal to 0. Now, I look at that and I say, where is my double angle? Is it with cosine, is it with sine, or is it with tangent? It's with cosine. So if I look here at cosine, here's your thought process. I don't mean to tell you what to think, but this is just a good, kind of situation in which to, thought process to go through when you have an equation. First thing I have is when I look at this, I've got cosine is my double angle, so I'm going to ignore that. What is left? Just sine. So if only sine is left after I ignore the double angle, then I want to use just sine. So if you see here, I have an equation that has both sine and cosine in it. I have an equation that has just cosine, and I have an equation that has just sine. So we have three choices. So the best thought process, my mind, my opinion, is to ignore the double angle, because that doesn't really count. We already know that it's cosine, and see what do I have left over, and see if I can match up one of those angles with, or excuse me, one of those formulas with the trig function that's left. So since I only have sine, guess which one I'm going to use? The one that is only sine. Does that make sense?
How does that one come about,
Okay.
though?
This one?
Yeah.
We can prove that if you want to. I mean, not right this second, but they all can be proved. Proven? Proved? Proven? Okay. They all can be proven. Okay, so here I go. Cosine of 2x is now going to become 1 minus 2 sine squared x minus sine x equals 0. All right, so there I go. And the cosine 2x is this double angle 1 minus 2 sine x formula. Okay, and you know, as Caleb was asking, each one of these can be proven, but it would take a little bit of time in which to do that, but we certainly can. I'm not going to do that on video though. So I've got 1 minus 2 sine x minus sine x. All right, I know I want to solve, so I'm looking for x. I want to know what is the angle measurement. So what would be the best thing to do here? Can I factor out a sine? Why can I not? Because there's a 1. And this 1 doesn't have a sign involved with it, so I can't. How about we try to just put this in standard form? Okay, so let's bring out the sine squared first. So that's a negative 2 sine squared x minus sine x plus 1. Okay, so let's get it in standard form. I've got 3 terms. So a 3-term trinomial probably means I'm going to be factoring it binomial times a binomial. Now, it's always easier to stay on the positive, okay? So I want to get rid of this negative. So try to keep it positive if you can. So let's pull out a negative 1 and make that a positive 2 sine squared x. But by pulling out this negative, it changes the sign inside. So the sine x becomes positive and the 1 becomes negative. At this point, I'm going to have people in different camps. Some of you may want to go ahead and just start in with the AC method and doing the 2 numbers that multiply to give you negative 2 but add to be 1. Go for it. I'm not here to try to undo anything, but for those of you that like to do a little bit of mental math, then you can stay with me because this is going to factor into binomial times a binomial. This one's fairly simple because the only 2 things that can multiply to give us 2 sine squared x is 2 sine x and sine x. 2's prime. So the only 2 things I have is a 2 and a 1. Those are the only 2 numbers that I have that can multiply to give me 2 sine x. I don't have a choice. Same thing. I don't have a choice with this last term. It's a 1. It has to be a 1 and a 1. Nothing else will work. But the question comes, this is negative. So one of these ones has to be positive. One of these ones has to be negative. So we just throw it in and do a trial and error. I might get it the first time, but if it's not right, then I'll just flip-flop those signs. So what I have is the way to check that. What's 2 sine x times 1? A positive 2 sine x. What's negative 1 times sine x? A negative sine x. Do those 2 add to give me that middle term? They do. Yeah. So I'm good to go. So I'm going to make that solid. That's a negative, and that is a positive. Then once you have your binomials, I set them both equal to 0 and solve for sine x. So here, sine x equals 1 half. And on the unit circle, where is sine x 1 half? We see it right above. So we don't have to do extra work. So that's pi over 6 and 5 pi over 6. And then the second binomial is sine x plus 1 equals 0, and therefore sine x is going to be negative 1. So I look at my unit circle. Where is sine x? Negative 1, and that's at 3 pi over 2. So my solution is pi over 6, 5 pi over 6, and 3 pi over 2.